Here's another special case of a quadratic equation. Remember I told you the times you're going to use the square root property method are either when the first power term is missing or you already have some quantity in your equation being squared. See how we have this binomial quantity being squared? Anytime you have a situation like that, that equation lends itself beautifully to solving it using the square root property method. So what we're going to do is we're going to isolate this quantity that's being squared. First thing I need to do then is to get rid of this coefficient of 3. I want to have a coefficient of 1 times that quantity being squared. So I'm going to divide both sides of the equation by 3. And now I can apply the square root property. Something squared equals a constant. If you have that, if something squared equals a constant, you can in effect take the square root of both sides. And that something that was being squared will be equal to plus or minus the square root of the constant that you have on the right-hand side of the equation. And now we want to simplify that radical expression square root of 8. Remember how you break it down? Break it down into a factor that's a perfect square. You can take the square root of 4 and get the whole number 2. And now lastly, to finish solving for x, we simply subtract 4 from both sides. And we always write the term without the radical first and the term with the radical second, behind the plus or minus symbol. So our two solutions here to this equation, our two solutions are negative 4 plus 2 times the square root of 2 and negative 4 minus 2 times the square root of 2. These are exact solutions. If we needed an approximate solution, if this was a solution to a practical application, say an application in physics or some business statistics that we were doing, some business finance formula we were working with, if we needed approximate solutions, we would have to use our calculator to evaluate the square root of 2 and then multiply that by 2, add it to negative 4 to get one solution, take that approximation, multiply times 2 and subtract it from negative 2 to get our other approximation. These are exact solutions. We would have to use our calculator to get approximate solutions. Once again, this equation lended itself beautifully to the square root property method. Why did it? Because it already had a quantity being squared, and that made it perfect for us to come to this step to then say that that quantity that was being squared had to be equal to plus or minus the square root of the constant.